I'll show you synthetic division. It will only work for the first two examples because synthetic division only works when you're dividing by a binomial with degree 1 and a leading coefficient of 1. The process is to start with your divisor and set it equal to 0. Solve for x. Then I'm going to put that -2 into a corner box. I'm going to line up all the coefficients of this polynomial. So I have a 1x squared minus 2x plus 6. Skip a space and draw a corner box at the end. That's how you set up for synthetic division. We don't have to drag around all the variables, so it's a much quicker process. Start by always bringing down the first coefficient. Then we're going to alternate. We're going to multiply by the number up in the corner box. So 1 times -2 is -2. Then I'm going to add those. Multiply again. -4 times -2. And then I'm going to add. Now look at the answer we got over here. 1x minus 4 plus, and look at that remainder. So 1x minus 4 and the remainder. A lot quicker. But again, the problem is that synthetic only works in selected cases. Also, with synthetic division, we have to remember 0 placeholders, and if we forget them, we're just going to get a wrong answer without realizing we've made that mistake. Because we don't have the variables and the exponents to line up like terms. So I would still set the divisor equal to 0. I would still have to rearrange the other polynomial, putting it in standard form with placeholders, and the coefficients would be 2x squared, 2x cubed, my goodness, plus 0x squared minus 4x plus 1. Always bring down the first coefficient, and then you multiply. 6. Add. Multiply. Add. Multiply. Add. And because our original polynomial was 2x cubed, my answer, my quotient, would be a 2x squared. And my remainder goes over the divisor. In the other 3 examples, we cannot use synthetic division because coefficient of 4, coefficient of 2, and this one's not degree 1. So those we have to rely on long division. It turns out that the synthetic process we use to divide polynomials can also be used to evaluate polynomials. And that's 2 completely different things. Dividing polynomials gives you a polynomial quotient. Evaluating polynomials gives you a numeric value. But the same synthetic process can be used for both. So let's start with the warm-up question. The warm-up question asks us to divide. That's a key word we need to pay attention to. using synthetic division. Fake division, so not long division. This means we'll take the binomial that we're dividing by, set it equal to 0, and solve. We put the 2 in a little corner box for organization, and then we list off the coefficients of the polynomial in order, filling in zeros if needed. Bring down, multiply by 2, add, multiply by 2, add, multiply by 2, add. So since the directions asked us to divide, our answer would need to be a polynomial. 4x squared plus 3x plus 2, remainder written as a fraction. The answer is of that format because we were asked to divide. Keyword, pay attention to directions. Now let's shift gears and go back to something we've done before called evaluating. If we are asked to evaluate a function, given a particular x value, that literally means to plug the x value in for all of the x's. So we are going to evaluate by plugging in a 2 for all of the x's. And using order of operations. 4 times 8, minus 5 times 4, 32, minus 20, minus 8, minus 5, put it all together, and we get negative 1. So because the directions said evaluate, we want that value. Now here's the fun part. Look at that value. And look at the value in the remainder. We were using the same polynomials in both questions. So there is a theorem that says you can divide and the remainder that you get will be the same as the value from evaluating a function. As long, if we have the same polynomials to begin with. What I also want to point out is that this is direct substitution. So again, we could evaluate a polynomial just by plugging a number in. Or we could evaluate a polynomial by using synthetic substitution and finding the remainder. That will always be true. So let's look at a couple more examples. Pay attention to directions. Part A says, evaluate, so that tells us my answer needs to be a value, not a polynomial, using synthetic substitution. Part A, I would put -2, that's my x value that's given, followed by coefficients. It does not need any 0 placeholders. Bring down, multiply by -2, add, multiply by -2, add, multiply by -2, add. Because the directions said evaluate instead of divide, we do not need these values. All we need is the remainder. And we would write our answer indicating that the function evaluated at -2 is equal to 0. If the directions had asked us to divide, I would need the row of numbers that I crossed off instead, plus the remainder. We can check our answer using direct substitution. That's real substitution. That's when you literally take the function and plug in a -2. And we have to be careful about order of operations and the negatives. -2 cubed is -8. -2 squared is +4. And we're going to find that the function evaluated at -2 using direct substitution is also 0. So we know our synthetic substitution worked out correctly. Next example, to do the synthetic substitution, I have to fill in with zeros. Bring down, multiply by 3, add. Multiply by 3, add. Multiply by 3. Something I have done is not right. Multiply by 3 and add, that's not right. I made a mistake. And I don't want to start my entire video over. And I think I know what the mistake was. I left off a negative with the 8. So 1x cubed, 0x squared, 0x -8. So bring down, multiply, add, multiply, add, multiply. There we go. I'm going to get the 19 I was expecting. And again, because the directions asked us to evaluate, it's the remainder we need, not the coefficients. The function evaluated at 3 is 19. And we're going to find in this case, I thought in the first example it was easier and safer to use synthetic substitution because of the -2. And in this one, we're going to find that it's quicker to use direct substitution because it was such a short polynomial to begin with. And we get straight away to 27 minus 8. So they're both good methods, and they'll give you the same result. One might be easier than another, depending on the polynomials you're working with. Pay attention to the vocabulary. You need to differentiate between division and evaluating. You also need to differentiate between synthetic substitution and direct substitution. Those will be the key words.